So, I'm the President of the United States. So I received this message from the heavens. So my microwave dish, my SETI dish, finally captures something. And what it says is, in 50 years, or 13 years, we're coming to your planet. You gotta be ready. Now just imagine what would happen if that happened. A super intelligent alien race beamed down a message to all of us Earthlings saying, we're coming July 13th, 2030, and boy, you better be ready because the mothership is landing right on the front lawn of the White House or wherever you wanted to land on that day. The amount of resources that would be marshaled to try to figure out what to do would encompass the whole world. AI is just like that. So when this thing that I'm talking about happens, it's going to be exactly the thing that you're thinking about those super intelligent AIs. So the one thing I can tell you is they're not going to be like us. So alien means, different. These things that we're building are not going to be people. They might be really smart, they might be really good at all sorts of different things, but they're not going to be like us. They're going to be aliens. And they're going to be, I'm sorry to say, way smarter than every single person in this room. So this is an attitude that some are having, this emerging alarmism about the way this is going to go. But these words, demons, doesn't capture the essence of what's happening here. I don't know if any of you are turn-of-the-century weird fiction fans, but there's this guy named H.P. Lovecraft, who's a very famous American weird fiction author. And he espoused a view which is called cosmicism. And the essence of cosmicism is cosmic indifference. So what he was saying is basically, yes, there are these massively intelligent entities out there, but they're not good, they're not evil. They just don't give a shit about you even in the slightest. The same way that you don't care about an ant is the same way they're not going to care about you. And these things that we're summoning into the world now are not demons, they're not evil, but they're more like the Lovecraftian great old ones. There are entities that are not necessarily going to be aligned with what we want. So this transition is really, really massively important for our entire species to navigate. And going back to that thing that Sam Harris was saying, nobody is paying attention. This thing is happening in the background while people bicker about politics and what's going to be in the healthcare plan in the US. And underneath it all is this rising tsunami that if we're not careful is going to wipe us all out.
But before I do that, I'm going to tell you a little bit about quantum computers and why people care so much about them. There are literally tens of thousands of some of the brightest people in the world today trying to build these machines and understand them. And I'm going to tell you why. In my last 15 years of working on this type of stuff, I found that scientists divide up into two categories of zealots about this field. The first half are people who are absolutely entranced by the physics of these things. This quote is from a respectable scientist, in fact, one of the founders of this field, that may look a little strange to you who don't follow theoretical physics, but there is a very clear prediction that our most successful theory of nature makes, and that is that there are an enormous number, mind-bogglingly large number, of parallel realities, as real as this one, that have different consistent histories. So imagine a world where all of the laws of physics as we know them are obeyed, but different decisions were made along the way. different decisions at the level of tiny microscopic particles, different decisions all the way up to what you chose to eat for lunch and whether you chose to come to this session or not. Quantum mechanics makes a very specific prediction that all of those are as real as the thing that you remember. And this is bizarre because we don't see those other things. But science has reached the point now where we can build machines that exploit those other worlds. And quantum computers are perhaps the most exciting of all of these that we have within, or almost within our grasp right now. So people from a physics background love this. They want to understand the world. They want to understand the universe, how it all works. There's another type of person who tends to come from the computer science side that's like, yeah, okay, that's all great. But there's a different thing going on here, which is just as exciting, if not more, and that these machines that supposedly can do this wild stuff, let's forget about how they work, if you could build one, could solve problems that you could never, ever solve with any computer of the sort that we built. If you took every single atom of silicon in the world and made the most sophisticated conventional Intel-style processor that you could build, there are problems we know of that I could write down on a sheet of paper that you could never, ever, ever solve with that thing, that you could with this kind of machine. So that's very exciting. Humans use tools to do things. If you give humans a new kind of tool that can do things that you couldn't otherwise do, imagine the possibilities. So you may think, well, this is all fine and dandy, but aren't these things in the realm of theory and speculation kind of in the same regime as other futuristic things you may have heard of which may be allowed by the laws of physics but aren't here yet? That's not true. There are, in fact, many of these machines deployed now in openly available research centers following the model that was used to introduce supercomputers to the world. They're too big and ornery and difficult to operate to put in your home, too expensive also, but you can give them to a place which will manage them as a shared resource that will offer that service to the world. And there are two of these now. One of them is at the University of Southern California. So these types of computers now are being thought of in the same way. They're not terrifically powerful yet, but they're doing something completely different than what your computer does. And that thing is light flight. It gives these computers access to these new resources, maybe you could call them parallel universes, in order to do something that you couldn't otherwise do. Steve Jurvetson has been a longtime friend and investor in the company, and for those of you who don't know him, he's a Silicon Valley investor who's probably the smartest VC that I know of, and certainly the one that's the most attuned to technological trends. He's on the board of SpaceX, Tesla, Synthetic Genomics, which is Craig Venter's company that's trying to build artificial life, and D-Wave, and that's it. And this is his particularly poetic way of framing the difference between the machines we build and conventional computers. This is what they look like. There are two of them. These are from our lab in Burnaby in British Columbia. From the outside, they look like giant black monoliths, big metal boxes, about 10 feet on a side, 12 feet tall. And they are powered, they have a fridge inside them, a refrigerator that cools these chips to almost absolute zero. Just a wisp, a fraction of a degree above absolute zero. Hundreds of times colder than interstellar space. Amongst the coldest and most isolated and extreme conditions that humans have ever been able to engineer. These fridges, interestingly enough, which are called pulse tube dilution refrigerators, have a thing called a pulse tube, which emits a sound roughly once per second which sounds eerily like a heartbeat. So if you have the opportunity to stand next to one of these machines, it is an awe-inspiring thing, at least for me. It feels like an altar to an alien god. They really are impressive machines. At the heart of this big box is a tiny chip about the size of your thumbnail. And on this chip resides all of the wonder and magic that makes this thing go. I'm not going to describe in any mathematical detail how it all works, but let me give you an analogy. In quantum mechanics, there's this concept that a thing can exist in two states which are mutually exclusive at the same time, quote unquote. And I'm using those words because the English language was developed before we had concepts to describe what these things actually are doing. But I'm going to give you a roundabout way of understanding this. Imagine that there really are parallel universes out there, and now imagine you have two that are exactly identical in every respect, all the way out to the horizon as far as we can see, down to the last little atomic detail of every single thing, with only one difference. And that's the value of a little thing called a qubit on this chip, which is a contraction of quantum bit. And that qubit is very much like a bit or a transistor in a conventional computer. It has two distinct physical states, which we call 0 and 1 for bit. In the conventional computer, these are mutually exclusive. That device is either one or the other, and never anything else. In a quantum computer, that device can be in this strange situation where these two parallel universes have a nexus, a point in space where they overlap. And when you increase the number of these devices, every time you add one of these qubits, you double the number of these parallel universes that you have access to, until such time when you get to a chip like this, which has about 500 of these bits, you have something like 2 to the 500th power of these guys living in that chip.
Oh yeah, that sounds like fun. Little men, demon things that we want to bring over, right? And that's the whole thing with 2030 and the stuff with climate change. Who's going to be blamed for it? We are. Because when they bring these things over, they're going to destroy the atmosphere. Those things, in my opinion, cannot live and adapt inside of this realm that God created to keep them out. That's why they do rituals to summon them and bring them over. But they temporarily are here. They're still on the other side. Yeah, it sounds like crazy talk, but guess what? It's really what's happening.